Engine. On the top left side is the engine that will use the fuel. Recovered energy. All the other images are a result of the recovery of waste energy that will use 90% of the fuel to do work. Battery chargers. On the right of the engine is a shaft coupled to the engine shaft. This shaft has sheaves that drive automobile alternators to charge batteries. There are enough of these alternators to charge batteries that will present enough load on the engine to make it run at best efficiency. The output desired is to be constant at 149 kilowatts produced in 1 hour. Jobs created. The service of carrying batteries to homes and tricycles is a way of earning for food and for a living. There are other forms of jobs that could be seen later. For this system, 6 jobs are created at PHP 25,000 per month. Water. The production of water is represented by bottles. The system will produce 1,942 liters per hour. Traditional salt pond. On the right side is the salt pond that depends upon the heat of the sun to evaporate water. This system has already taken a lot of the water for drinking, thus the salt will contain less water. The recovered free energy will serve miniature salt ponds. 70 kilograms per hour will be harvested and sold at $300 per metric ton. Copra. The drying of copra is traditionally by the sun. This system will use recovered free energy to dry the copra. The system will prevent the growth of aflatoxin, and this product will be acceptable in other countries for export. Bongo Island. Many houses in Bongo are on stilts. This new system will supply electricity, water, salt, and drying energy for their fish catch for drying. At a horsepower 200 and above, Bongo could have community refrigeration requiring no electricity, but free energy from the fuel. Tricycles to electric and/or hybrid electric. Tricycles will receive charged batteries from the system. For pure electric vehicle, the tricycle could be built with the wheels driven by electric motors. By a very simple solution, the wheel on the passenger's side are provided with sprockets that are driven by an electric motor attached behind the passenger's seat. Controls. These controls are prefabricated and are attachable. Part of the job creation purpose is the training on this easily attachable system, and people, young or old, man or woman, will enjoy learnings in the system. Eventually, they might pursue with great interest in courses in systems that are offered in universities for higher level jobs. Technical diagram. Salient assumptions: 200 horsepower is assumed operating at 100% load and 30% efficiency. Jacket water is circulated and is about the same volume as is 10 degrees Fahrenheit difference between jacket water and sea water at outlet. Design transfers. Latent heat of condensation. From generated steam to the preheated sea water to reduce heat requirements for providing the latent heat of vaporization. To generate steam, condensed water is expected to be hot at about 210 degrees Fahrenheit. Concentrated brine will be discharged to the miniature salt pond where the produced salt crystals will be dried. Heat from water. The remaining heat from the condensed steam is in its proper state to drive lithium bromide absorption chillers. RXC11. Hot water chiller. Technical parameters. These are the major parameters controlled by the independent automated control system for the engine, distributed, receiving set points in contrast to those controlled at a control center in real time. Pre-designed, prefabricated, for assembly. The control system is a sealed and assembled system provided with terminals for the connections to sensors and actuators. The sensors and actuators are identified as compatible with the distributed control system, including the fuel. As encased, this control system may become the basis for the teaching of the programming of the language C, which is the native language of microcomputers like the Arduino and others. The relationship between the distributed and the SCADA. The distributed system will operate independently with or without SCADA, as it is programmed for specific parameters for the engine. It brings the engine to operate at its most efficient operating conditions. The SCADA monitors parameters outside the engine for the purpose of optimizing its service to community. For example, charge of batteries at each location, like tricycles, homes, community centers, theaters, fingerling ponds, etc. Forecast of batteries needed for kilowatt-hour needed in time. SCADA also monitors fuel quantity in relation to kilowatt-hour forecast. Why the SCADA? The installations are small and when installed. In very many locations, there are certainties for individual failures. Failures will require the management of such incidents with the use of human interventions. The incidence of failures influence the value of the service to the point that a system may be abandoned. The SCADA is able to monitor parameters. Its algorithms are designed to be able to predict/forecast possible failures. The SCADA will notify the installation site, or ship parts or components in advance, and the interruption of service is minimized. Quote from the WHO. According to the World Health Organization, WHO, 2.1 billion people lack access to safe drinking, with people in rural areas with limited infrastructure being mostly affected. Within the Philippines, this concept manifests in that 91% of the country's estimated 100.7 million population have access to basic water services, but access is highly inequitable across the country, with regional basic water services access ranging from 62% to 100%. To combat water insecurity, government bodies, non-governmental organizations, NGOs, and independent parties have collaborated to ensure that all citizens have access to clean drinking water in the Philippines. Drying lake and SEA water harvests. In addition to the drying of copra, rice, corn, and other fruits, this system will radically increase the production of dried Tuyo, Danggit, and other fishes, dried mango and other fruits. Drying is no longer dependent upon the sun-drying tradition. The drying of scallops could become within very easy reach as the heat of the sun is supplemented by heat from the dryer here. More local sources of dried imported products may sprout. Traditional salt farms. Salt farms normally allow water to come in during high tides. They keep the water there and allow the sun to evaporate the water. This new system, while seawater is heated to boil into steam and made to condense for drinking, salt in this seawater is left behind by water and discharged into a small pond or a large basin that is allowed to dry up naturally, or provided with free energy recovered from the fuel. Imagine the advantage of the production of 70 kilograms per hour of salt here. And this salt production can happen in a rain or shine weather. This salt product that is also independent of dust and/or pollution. Traditional drying of rice. Once harvested, rice may be placed on a mat on the ground at a non-shady place. This mat is made of different materials. Some are from bamboo or from leaves. Farmers know when rice is good enough to put in sacks and bring them to rice mills for milling. Rice mills. Some rice mills are ambulant. Their mills are powered by gasoline-driven machines. For milling to be less expensive, this project would replace the gasoline-driven to battery-driven machines. System rice drying. A mat is placed on a surface that is heated by the free energy that the system has recovered. Drying is now independent of the weather, be it raining or not. Drying will now be faster. To the advantage of rice, the system is not like the traditional way. Moisture that comes from the ground to the mat is not present here. Electric motors similar to the picture on the left will replace the gasoline-driven engine, pointed by the arrow. The energy cost per kilogram of milled rice will become lower. Thus there will be savings for the community. Metering. Every customer has a billing meter up there. The assumption is that one customer or more could tinker with the meter and pilferate it. Let us decide to believe that this assumption is human error of judgment. How? Very simply, turn the business over to the community. They will elect officers from among their respectable community members. They will respect each other's ownership of the business. They will share profits among themselves in joy and increased motivation. Their behavior and their thinking becomes for us, and not for me. This describes the Cooperative Credit Union of Sta Cruz Parish in Manila, which started in the fourth quarter of 1968 with officers, Col Lazaro, Mrs. Lazaro, Kiko Sionco, Caring, a lady selling newspapers, Mrs. Medina and others. Tricycle. A family that could afford a car would buy one for transportation. If they have money, they may buy more, and even more pricey. But that is, sometimes, dictated by income or possessions. A car is made to cater to a specific society. In some countries or societies, the means of transportation evolves to fit to the economic conditions of the society. Evolution of transportation. After the Second World War, the wheelless jeep became converted into a jeepney to bring people from one place to another for a fee. In some trips, jeepneys wait to be filled by passengers. At some point, a tricycle appeared to bring a smaller number of passengers to their destination. In both cases, a study might yield numbers for the amount of money spent for gas for each passenger, and for each kilometer, or mile. An internal combustion engine, ICE. Cars, buses, jeepneys, tricycles, boats, etc., using ICE, all throw away energy from the fuel that is not used to drive the shaft. Here's the trick. The less the shaft uses, the lower is the efficiency of the engine. In addition, the lower the efficiency, the more energy is discarded into the environment. This project will operate at a constantly high efficiency. How? The ICE will always operate at or near the most efficient operating conditions. Charging shaft. The shaft on the left, driven by the engine, presents a constant high load to ascertain that the engine always presents savings for the community. Many batteries are being charged. As the charge increases, the charging current will decrease. This decrease in current will be compensated by other batteries being charged to keep the shaft a heavy load on the engine. This shows many batteries are being charged. Back to the electric tricycle. The power demand of the tricycle is given by the battery. The efficiency from the battery to the shaft is always constantly high, approximate 90% or more. Operation is more efficient than the ICE-driven tricycle. The hybrid electric tricycle is discussed in the next slide. The hybrid electric tricycle, HET. What does this mean? First, the ICE is made to run only at very high efficient loads. This means heavy loads, as in many passengers, and higher speeds. At these high loads, the ICE would be operating at its intended load. Second, the electric motor takes over at any time that the demand of the tricycle is outside the high-efficiency operation of the ICE. This means that the electric motor runs until brings the tricycle to the most efficient running condition of the ICE. Third, at a certain charge level of the battery, the sensor will run the ICE so that the charging load plus the shaft load equals the ICE load high enough. All decelerations will drive the electric motor as generator to charge the batteries. Fourth, the electric motor is attached to the right wheel of the tricycle, and the ICE is driving the left wheel. The easy high savings technology to learn in the community. This technology is like installing Christmas lights. The battery is the power source. Connecting wires are identified in colors. Schematic wiring diagrams specify the colors. Recommended voltages for tricycles are low to ascertain that safety is assured for all. All connections are recommended to be audited by the community officer. As seen in the presentation, the following are the features. First, one fuel produces electricity plus water plus salt plus dryer plus refrigeration. Second, efficient use of energy from the fuel at approximately 90%. Third, the project cares for A, the community, B, the environment, and C, the planet. Fourth, all of the technologies discussed here are technically accepted in engineering practice, and are part of the board examinations. The whole integrated system seems to be absent in the known world. Fifth, All of the concepts related to human beings and their communities have been part of goals of government, NGOs, religious communities and organizations, and ecumenism movements.